So the video you're just about to watch comes from one of my online preparation courses, either the theory preparation course, or teaching in pool and classroom, or the full IDC preparation course. There's lots more information in the link below, and there's also lots more information at the end of this video. Anyway, enjoy the video. I hope you learn from it, and I certainly hope to see you again soon. Thanks. Right, I just want to explain something more about pressure-volume relationships. So this chart behind me, this should be quite familiar to you by now. You've seen it in various PADI manuals. Now, instructors usually start off by talking about balloons and how they get smaller on the way down. But as you've seen in the last couple of lessons, they soon move on from balloons to talk about how it affects our breathing rates, the effect of gases in our cylinder, partial pressures, and also density. And in our last lesson, we looked at a really simple way that we could work out all of those things. But I think that this chart could be explained. It could be explained in an easier way to people. So I want to spend a little bit of time explaining something that's really simple, and when you see it, it's really obvious, but it's often missed by some PADI instructors. And I really want you to get this, and I'll tell you why, because when it's your turn to teach your future students, I want you to be able to explain this in a really simple way and explain exactly what's going on with pressures and volumes. Also, understanding this, it's a really easy way for you to answer some of the questions that you're going to find on some future PADI exam papers. Now, it was Sir Robert Boyle that came up with this idea. It's known as Boyle's law. But seeing as Robert Boyle lived from 1621 to 1697, it's not surprising that he didn't say, when you go to 10 metres, you increase pressure by 1 atmosphere and volume is halved. He wasn't a diver. He didn't say that. He didn't even know that a human could possibly breathe compressed air underwater. So he didn't say any of this. But what he did say, however, was very simple and very logical. He said that if you double the pressure, you halve the volume, and vice versa. So it's a true, simple relationship. If you halve the pressure, you double the volume. So it's not that this chart is wrong, it's just that sometimes people miss the point of it. So let's look at it closer and see if it's always true. If we double the pressure, we halve the volume. So we'll start at the beginning. If we go from 1 atmosphere to 2 atmospheres, the volume goes from 1 to 1/2. Okay, that's the most obvious example. We knew that. We've heard that so many times before. We know it's true. That bit is clear. But what about other numbers? What about, say, 3 atmospheres to 6 atmospheres, 4 atmospheres to 8 atmospheres, 5 to 10? What about those? Well, let's look at 3 atmospheres to 6 atmospheres. We can see here that the volume goes from 1/3 to 1/6. So that is half. It has halved. Okay, it might not be useful to use fractions when we're trying to describe volumes. So instead of fractions, what we could do is give it a value. Let's say that we've got a balloon that's at 3 atmospheres, which of course is 20 metres. Let's say it's got a volume of 10 litres. We need to be careful not to confuse depth with pressures. As we saw that on the box method, depth is never important in calculating volume. It's always the ambient surrounding pressure that counts. So we got 10 litres at 3 atmospheres. So what would happen if we took it to 6 atmospheres, which of course is 50 metres? Well, we've doubled the pressure, 3 to 6, so it should simply halve the volume, 5 litres. But does it? Is that what happens? Was Sir Robert Boyle right? Did the balloon halve from 10 to 5 litres when we doubled the pressure? Well, we could prove this by using the box method. We could take the balloon up from 3 atmospheres to the surface, so that's 10 times 3 is 30. then bring it down again to 6 atmospheres, so that's 30 divided by 6 is 5. So it works, it did. But Robert Boyle's method is far simpler than using the box method if there's a relationship. It also works with other fractions. If you tripled the pressure, the volume reduces by 1/3. Quadruple the pressure, the volume decreases by 1/4. So a true relationship between volume and pressure. Now, in a moment, I want to talk to you about capillary depth gauges. What, you might ask? That was a bit unexpected. This is supposed to be a theory lesson about physics, and you want to start talking about equipment. You want to start talking about depth gauges. Why do you want to do that? Well, actually, that's a good question. And I will get round to answering it. I'll answer it in a minute. But for now, do you know what? I've just had a great idea. It's about this pressure-volume relationships. It's a great idea. See, I've got a glass, and all this talk has given me, well, a good idea. You see, in the future, if I was to lose my computer, I won't have a depth gauge. But with your help, I can use my glass. So let's go diving, you and me. We'll dive together. You take your computer, I'll take my glass, I'll hold it upside down so the air doesn't bubble out. We'll stick very close together. You keep a close eye on your computer. And when we get down to 10 meters, what I want you to do is give me a nudge, and I'll look to see where the level is here, and I'm going to mark it with a pen. 10 meters. Okay. Now, as we've doubled the pressure, the volume should have halved. But then what we'll do is we'll go down to 20 meters. You keep looking at your computer. Give me a nudge when we get to 20 meters. We'll have tripled the pressure. So we'll see that the air should have squashed to 1/3. And I'm just going to write 20 when we get there, so I'll know where it is. Then we'll go a little bit deeper. We'll go down to 30 meters, 4 atmospheres. We'll have quadrupled the pressure. So the air would have been up to about here, 30 meters. So I'll put a mark. And then what we'll do is we'll come up and put a safety stop in at 5 meters. So we'll come up slowly. You give me a nudge when we get to 5 meters and I'll mark the glass. But I already know roughly where that mark's going to be, because 20 meters is 3 atmospheres. 5 meters is half of that, 1.5 atmospheres. So according to Boyle's law, it should be halfway between the 20 and the surface, around here somewhere. Woohoo! See, now I've got a depth gauge, and it's built according to Robert Boyle's laws with true pressure-volume relationships. And whenever I go diving, I can use this as a depth gauge. Okay, you've probably realised this is exactly what a capillary depth gauge is. A capillary depth gauge, of course, isn't a glass, but it's a tube wound around like a circle. And the real gauge has got more depths marked on it. But it works like this, precisely on Boyle's law, pressure-volume relationships. And actually, that's why people like to use it for altitude diving, just a simple open tube based on physics. Regardless of whether you're at sea level or high up in a mountain with a lower surrounding pressure, as that pressure around you doubles, the volume will halve, allowing to use your dive tables based on the depths that are shown on your gauge. I guess the only downside on a capillary depth gauge is that the shallower depths has a great big gap between them, and the deeper that you go, the depths up here, they're all squashed together. But anyway, this is a capillary depth gauge. Now, we can try some questions relating to all of this in the next section. As always, the questions I've popped on there are very similar in content and format to the ones that you're going to find on PADI exams. So good luck with those, and I'm really looking forward to seeing you in the next video. So welcome to the full IDC preparation course. I'm really excited about this program. The reason why I'm so excited is because it's absolutely jam-packed with all of my wonderful secrets that I teach throughout my whole IDC, which is, of course, why it's called the full IDC preparation course. So we'll have a little look. The screen we're looking at the moment is called your course player. This is going to become really familiar to you in the next few days. But let's have a look here on the left-hand side, and we'll find out what's involved down here. So down here we've got our theory topics: physics, physiology, equipment, diving skills, RDP, all that stuff. We'll have a little look a little bit deeper into those in a minute, but I want to talk to you a little bit more about what's in this program. So we scroll down a bit here. We've got PADI standards and procedures, right up to date. You can see the very latest version based on this year's PADI instructor manual. And then when we go down here, we've got some really exciting stuff: teaching in confined water. So this is how to make your confined water teaching presentations really effective, and more importantly, really relevant to your students right from the very start. It's a very powerful way of teaching, I'm going to show you here. Perfect for the real world, of course, but it's also really good for IDCs, and it's great for PADI instructor exams as well. So loads of powerful stuff in there. And scrolling down a little bit further, right down to the bottom, teaching in the classroom. Here, I often get asked, I find people on PADI IDCs, they're really not too sure how to structure teaching in the classroom. It's easier than you think, but it needs to be entertaining. It needs to be full of relevant stuff for your students. And in here, I'll explain how all that works. So let's go right back up to the beginning again and look at these theory topics. Let's see what's in here. We'll pick physics for an example. It's always everyone's favourite, isn't it, physics? So we click on physics and we find that physics is broken down into different subjects here. We'll pick on any one of them. Let's pick on, I don't know, effects of pressure. We'll have a look at effects of pressure. And here we see there's a video playing. So it's a lesson. It's going to last for 15 minutes. It shows you here. I'm going to stop the video. So we're in control. We can stop it, start it. We can get rid of this panel on the left-hand side by clicking these 2 arrows up here if we want to. Bring it back again. Of course, we've always got full screen, so you can put full screen on, sit back with a cup of coffee and just listen to the whole thing. Gives you, a lot more information. And then what happens, also you've got down here is complete and continue button if you want to, and that will stop the video and take you on to the next lesson. And after all of these lessons, the next lesson always is a quiz of what you've just heard, just to make sure you fully understand it. So here we've got like a question up here, a very PADI type question worded in the way that PADI would word questions. And just like PADI exams, 4 different answers that you can choose from. Find out which one is the one that you think is best suited. And just like on PADI exams, but not like on PADI exams, is if we just pick let's just pick one answer that's the wrong one and click on confirm. We find out it's the wrong answer, but not only that, not only will it tell you what the right answer is, but it will tell you why. So it will give you tips and advice where you've gone wrong to help you succeed. So all of the theory lessons are very similar to this. If we work down, loads of RDP questions, loads of diving skills and environment stuff, loads of videos on there to help you if you're not too sure of how all that stuff worked. When you've done all the theory, gone down here, what we can do then is, if you want to at this stage, go to the final mock theory exams. And here we find right up-to-date theory questions here, all based on like the latest questions that PADI are asking on their exams. So here we've got PADI theory mock exam A. We go all the way A, B, C, D, and E, 2022 version. As you can see, all of the questions where relevant are in metric and imperial, so it's really great for anybody, or for everybody, I should say. And then the format and the content of these exams is the same as you'll find on your final PADI IE. The wording's not the same. The wording of the questions aren't the same. That's not the objective of this. It's not to tell you what the questions are going to be. It's just so that you can understand the theory, and not only understand it, but that you can teach it to other people as well. It's another objective of this course, really. Then once you've done the mock exams, you can go to the answer key here, and you can check your answers. And clearly, if you've got some wrong, you don't understand them, or you've forgotten, you can go back to the lessons and catch yourself up again. So you can work at your own speed, your own pace, and it's fun working through it this way. Then we've got PADI standards and procedures. Again, we've got these are all based on this year's PADI instructor manual, so right bang up to date with the new programs that PADI have introduced this year. They're all in here, so you can teach yourself and work your way around the PADI instructor manual. Loads of questions. There's 50 questions, 5 exams here. Each one's got 50 questions on it. Exactly the same format, exactly the same content as the ones you'll find on your final PADI instructor exam. Once you've done those, you can have a look at your answers. You can check them with your answers. So here I've just gone to PADI Standards Mock Exam E, for example, answers. And here you can check your answers, see if you've got the right ones or not. But of course, a standard exam isn't really to do with your knowledge of standards. It's do you know where to find the standards in your instructor manual? PADI call it an open book. You can have your instructor manual with you when you take the exam, and what you really need to do is know where to find the answers in the manual. And to help you there, in this answers document, we've got all of the questions that we've asked before, but not only have we given you the correct answer, but also the page in the current instructor manual as to where you'll find the answer. So you can go back to the instructor manual and find out where to find the answer. So that's standards and theory dealt with. When we go to confined water, this is brilliant stuff here. So teaching in confined water, understanding your students. This really is good, finding out how your students learn, the psychology behind the students, or behind the way that you can teach your students. Or actually, I prefer to word it a different way. The psychology, not the way that you teach it, but the way that they learn it. So we've got like subjects on there, like on psychology, positive coaching, which is a really fantastic way of teaching people, correcting mistakes. And it gives empowerment to your students. It gives them ownership of their own learning, and it gives them empowerment as to the judge of the success is down to the student. So really it is the next thing here, student-centered training. It truly is explaining how we can make our teaching student-centered rather than instructor-centered. And when you start doing that, it's amazing how quickly students learn and how effectively they pick things up right from the beginning. Once again, this is perfect for IDCs and perfect for IEs as well. And of course, really perfect for the real world as well. Teaching in the classroom, I've already explained. It really does explain to you what we need to achieve in the classroom to get your students, in the right direction, and being able to understand and probably relate different subjects to each other. So lots more than that in the program. It's really full of fun. I'm really looking forward to working with you through this. And please, why don't you join our Facebook page? We've got the Prior Knowledge Family Facebook page. If you join that, then you can let me know how you're getting on with this program. So I'm really looking forward to the future with you. Thanks now.